All right, so today in class we discussed simplifying radical expressions. Remember, our goal is to try to get the smallest possible number inside the radical. Remember, the ratty in the can, the radicand. So number 3 on your homework tonight is the square root of 20. We want to try to simplify that to get the smallest number possible inside the radical. So one method of doing this is rewriting the square root of 20 as the product of two other radicals. You could look at the square root of 20 and see that it's composed of 4 times 5. The square root of 20 is equivalent to the square root of 4 times the square root of 5 because our product property of radicals. Well, the nice thing about this is that the square root of 4 is a perfect square. The square root of 4 is 2 times the square root of 5. Square root of 5 is not a perfect square and cannot be broken down into the product of a number and a perfect square, so this is the simplified version of the square root of 20. This is our first method. The second method we could use to simplify the square root of 20 would be to use a factor tree. A factor tree takes a number and breaks it up into its prime factors. So we can take the square root of 20 and break it up into 2 times 10. 2 is a prime number, so we can leave that, but 10 is not. 10 can be broken up into 2 times 5. Now, since I'm taking the square root, I want to cancel out groups of 2 of the same number. So, for instance, I have 2 2's. In other words, I have 2 squared. The square root of 2 squared is simply 2. What I'm left with inside of my radical is a 5. So the square root of 20 can be written as 2 square root of 5, which agrees with the answer we got in method 1. Let's take a look at another example using factor trees. I have the square root of 48. I want to simplify it. So I'm going to break 48 up into its prime factors. I personally always like to start with 2 because I know 2 is a prime number. So 2 times 24 gives me 48. 2 times 12 gives me 24. 2 times 6 gives me 12. And 2 times 3 gives me 6. So the prime factorization, or the prime factors of 48 are 2 times 2 times 2 times 2 times 3. That gives me 48. Again, I want to look for pairs of the same number. So right here, I have 2 2's, or 2 squared. Again, the square root of 2 squared is simply 2. Times, here's another pair of 2's. 2 squared, again, the square root of that is 2. Times, I still have 3 inside the radical because I do not have a pair of 3's to put outside of my radical. 2 times 2 is 4 times the square root of 3. So the square root of 48 can be written as 4 square root of 3. Number 15 on your homework tonight involves radicals with variables on the inside. We still want to get the simplest, smallest value inside of our radical. Let's decompose this into 2 times the square root of a to the 4th times the square root of b to the 5th. We can look at a to the 4th as the square root of a squared raised to the second power. Because remember, when we have a power to a power, we multiply. A squared to the second power is a to the fourth. We can look at b to the fifth as b squared to the second power. That gives me b to the fourth times b, because we need to get b to the fifth. B to the fourth times b to the first, remember multiplying like bases, add your exponents, is b to the fifth. So I'm simply writing an equivalent form of b to the fifth as the square root of b squared squared times b. Whenever I take the square root of something squared, I'm left simply with that value. So I have 2 times a squared. The square root of a squared squared is just a squared. My second radical, I can look as 2 different pieces. I can look at it as b squared squared times the square root of b. Again, the square root of b squared squared is simply b squared. So I can write this as 2 times a squared times b squared times the square root of b. Again, my goal when simplifying these radicals is to get the smallest possible thing inside of the radical. B is the smallest possible value to be left inside of the radical. Since I could simplify a to the fourth, the square root of a to the fourth as a squared, and the square root of b to the fifth as b squared times the square root of b. In the last example, I claimed that the square root of b to the fifth is equal to b squared times the square root of b. I want to take a minute to just take a closer look as to why that's true. If we take a look at the square root of b to the fifth, and we look at the prime factorization of b to the fifth, the prime factorization of b to the fifth is b times b times b times b times b. Those are the simplest factors of b to the fifth. Again, when I do a prime factorization or a factor tree, I want to look for pairs of the same number. So right here, I have a pair of b's. In other words, I have b squared. The square root of b squared is simply b. I have another pair of b's here, so b squared, again, the square root of that is just b. And I'm left with 1b inside of the radical. Well, b times b we know is b squared times the square root of b. So the square root of b to the fifth is b squared square root of b.